Good afternoon, girls. Today we have discussed about constraints. So, what is meant by constraint? A constraint motion is a motion which cannot proceed orbitally in any manner. We have simply said the constraint is nothing but a condition imposed on a particular particle or a system. That is, the particle motion is restricted to occur only in a particular space. Okay. For example, we have considered a particle moving along some specified path or in surface. The motion along some specified path is a simplest example of constrained motion. So here the constrained motion is commonly represented by the letter k, where the number of degrees of freedom is reduced to 3n minus k, where 3n is a number of coordinates, k is a constraint imposed on that particular system. For example, we have considered a particle, that is a bead is made to slide on a wire. Constraint required that the position of the bead will be lying on a wire. The condition imposed on the system by the constraints will be written in mathematical relation which satisfies the coordinates of a particle with respect to time. Thus, the imposing constraints on a mechanical system is to be simplified by the mathematical description. The way in which a constraint reduces the number of coordinates needed to specify the configuration of a system. For example, let us consider a motion of a simple pendulum. The motion of a simple pendulum confined to move in a vertical plane. Here we considered a two coordinates. One is Cartesian coordinates and another one is polar coordinates. The Cartesian coordinates is represented by the letter x and y, and the polar coordinates is represented by the letter r and theta. With respect to the point of suspension of the simple pendulum, both the coordinates are dependent with respect to the point of suspension of a simple pendulum. However, the motion of a bob is not free but takes place under a constraint, that is, the distance of the bob L is remained to be same from all the time. The condition imposed by this constraint can be expressed in the form of an equation either in Cartesian coordinates or in polar coordinates. In Cartesian coordinates, the equation can be represented as in x and y terms. X square plus y square equal to L square. So x square plus y square we have commonly written as r square. So r square equal to L square, where r equal to L. Okay. So or here the equation can be written as r1 up to rn. So I having a values of 1 to 3 up to n. So by substituting values for the I, we have calculate for first system up to nth term. The equation for first system can be represented as R1 equal to R1 of Q1 Q2 up to Q3n minus k comma t, where Q1 Q2 Q3n minus k are the coordinates of first system, second system. Next, the Qn 3n Q3n minus k is a 3n coordinate system with constraint imposed on that particular system with respect to time. So the nth term can be written as Rn equal to Rn of Q1 Q2 up to Q3n minus k comma t. Okay. Next, the classification of constraints. So the classification of constraints is holonomic, non-holonomic, rheonomic, scleronomic. The holonomic constraints is a constraint which will be expressed in the form of f of I equal to f of I of q1 q2 up to qn comma t, which will be equal to 0. So I having a values of 1 2 3 up to n. Where holonomic constraints are the constraints, it will be independent of velocity. For example, a cylinder rolling without sliding down an inclined plane. So next, non-holonomic. Non-holonomic constraints are the constraint relations or irreducible function of velocities. For example, a sphere rolling without sliding down on an inclined plane. Okay, so next, rheonomic. A rheonomic constraint is a constraint relations will be dependent on time. For example, a bead sliding on a moving wire. Next, scleronomic is a constraint relation. It will not be dependent on time. For example, a rigid body. In case of rigid body, it will be not dependent on time. So these types of constraints are called as scleronomic. Okay, these are the types of constraints. Thank you.